Hey guys, today we're finishing 6-4 that we didn't finish on Friday when we did our live class. I also have a little thing that I forgot to teach you in 6-2, so there'll be a second short video, so watch both of these because your homework will have both of these concepts in it. So before we finish chapter 6.4, I want to review kind of what we did at the very end. I'm going to give you another example. So if you did the homework or if you're feeling pretty confident, I would pause now and try these two examples. The first one is going from polar to rectangular form, and the second one is going from rectangular to polar. Now, if you're like, there's no way I could pause this video, that's fine. Stick with me. I'm going to jump over here, and I want to remember our coordinate conversion. So you should have this in your notes. We did this together, so I told you that if we've got point P, it has a point that's x and y, and it has the same point that's r comma theta. Now, if we want to find x, then that's the same thing as r cosine theta. So if I have r and theta, multiply r times cosine theta, that gives you x. Similar idea, y though is r sine theta. You use these to go into rectangular form because it's both the plural or both the polar parts. Next, if I want to find r, I know that r squared is equal to x squared plus y squared. It's like Pythagorean theorem, it's like distance formula, all that fun stuff. That's how you find r. And then theta, you find theta by doing tangent of theta equals y over x. So each of these pieces you can find using the two of the other pieces essentially. So this is key. If this is not in your notes, this needs to be like highlighted, underlined, starred, whatever. So we're going to use those concepts in order to find what I have asked you to do here. So to go from polar to rectangular, I gave you polar points. This is your r and that's your theta. So if I want to find the rectangular points, we're going to do x equals, well, we just learned that x equals r cos theta. Well, we know r in this case is 2 and cos is negative 200. So if I do 2 cosine negative 200 in my calculator, I'm going to get negative 1.88. Don't trust me, try it yourself. Okay, now I'm going to find y the exact same way, but I'm going to use sine. So I've got 2 sine negative 200, and I find that y is 0.68. So then my new point here is negative 1.88 comma 0.68. This is the xy that corresponds to that p theta. All right, now I'm going to go vice versa. Now I'm going to do rectangular to polar. So this is my x, y, and we want to find r theta. So we know that r squared equals x squared plus y squared. R squared equals 1 plus 49. R squared equals 50. So we're going to square root to both sides. R equals radical 50, which we know is the same as 5 radical 2. Make a little t-chart if you, or tree diagram if you have to. 2 and 25. 25 is 5 and 5. Easy peasy. All right, now I'm going to do theta. So that's tangent of theta equals y over x, 7 over 1. I'm going to put in my calculator inverse tangent of 7 divided by 1. And remember, we're in degrees this whole time because this was a degree over here and I want a degree on this side. So if you're not in degrees or you're not getting the same answers as I am, it's probably because you're not in degrees. So my theta is going to be 81.87, it looks like. And so my new rectangular coordinate is 5 radical 2 comma 81.87. You can think about what these would be. So my common sense tells me P for rectangular to polar, that's in quadrant 1. Well, 81 is also in quadrant 1, and I've got a positive distance, so that's all in quadrant 1, so that's good. I don't have to do anything crazy there. On the first one, 2 and negative 200. Well, negative 200 would be like this way, and it would be over here in the second quadrant, and it would be up 2, and then negative 1.8, and then positive 0.68. That's also in the second quadrant. So we're good. We don't have to do anything crazy. We just can use our answers, okay? So now we're going to do what I didn't get to on Friday, converting equations, and we're going to start going from polar to rectangular. So I know that it's in polar coordinate form because I've got r's and I've got thetas. R's and thetas. We have those conversions that we just looked at. So if I have, like, I can replace any of these pieces for what they're equal to. So like x is equal to r cos theta. So if I have r cos theta, then I'm able to replace that with an x. So that's something I want to remember. If I have like r squared, I can replace that with x squared or y squared, x squared plus y squared. Or if I had x squared plus y squared, I can replace that with r squared. So we essentially want to get things in terms of the other one here. So this is kind of like our conversion page where we're like, oh, if I have this, then I can exchange it or trade it or rewrite it as this. So right now I don't have any of those. I've got r and then I've got 4 cosine theta. However, if I get r squared or r cos theta, then I can change things out. So if I want to do that, I'm going to multiply by r on both sides. You can't multiply r on one side without doing it to the other side. It's not equal. So r times r is r squared. R times all of this, they're all being multiplied together. So I'm just going to make it 4r cos theta. I wrote it that way because I'm easily able to see r cos theta over here by itself, and then I've got r squared on this side. We just discussed that r squared could be rewritten as x squared plus y squared. Look, it's equal to each other. Oh, I went too far. R squared equals x squared plus y squared. So if I have r squared, I can replace that with x squared plus y squared. Same thing with r cos theta. That's what x equals, so I can replace that with x. Now I magically went from having all polar variables, polar equations, polar all this stuff, to now it's all in rectangular form, x's and y's. Now x squared plus y squared is the formula for a circle, so all we have to do is get everything to one side and then do our favorite thing, complete the square, so that I've got a nice clean equation for my circle. So I'm going to minus 4x from both sides. X squared minus 4x plus y squared equals 0. Now I left this blank because, like we did at the beginning of the year, we have to complete the square. I want to write this as x minus something squared plus y squared equals something else. So I have to figure out what's going to complete the square. To complete the square, we have to do b divided by 2 squared. So off to the side, I'm going to do negative 4 divided by 2 squared. Well, negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm going to add 4 to both sides. When I add 4 to both sides, I now am going to do my perfect square on the left-hand side. So x squared minus 4x plus 4, that's a perfect square of x minus 2 squared. My other side is a 0 plus 4, so that just stays as 4, and that is fine. This is my answer. This is an equation of a circle, so this gives me a circle. And I know 2 things from here. I know what the center is, and I know its radius. So the center comes from what's being added or not being added to x and y. So I've got 2, and then I technically have 0. So my center is at 2, 0. And then my radius is going to be the square root of whatever 4 is. So square root of 4, and then we know that that's actually 2. So I've got a circle with center 2, 0, and has a radius of 2. So if you were to graph this equation in your calculator, and we'll talk about that in a little bit, this is what you would get out of it. Okay, let's do another example. I've got r equals 4 secant theta. Okay, well, if I had a cosine or sine here instead of secant, then I would immediately multiply by r on both sides to do exactly what I did on the last step. However, I don't have that. What's secant the same thing as? 1 over cosine. Okay, now I'm in terms of cosine. It's not yet what I want it to look like, and I don't like fractions, so I'm going to get rid of the fraction. I'm going to multiply by cosine on both sides. All I'm doing is algebra, guys. all I'm doing is algebra, so you're allowed to do this on both sides as long as it's just algebra. So that's what I'm going to do. Multiply by cosine on both sides, that crosses out. So now I've got r cos theta equals 4 over here. Just as we did on the other problem, I can replace r cos theta as x. X equals 4. That's it. There's nothing else for me to do. There's no y's, there's no r squares, there's no nothing. This is a fine answer. X equals a number. Do you know what shape that makes on my graph? It makes a vertical line at x equals 4. So again, if I were to graph this in my calculator, it would give me a vertical line at x equals 4. Again, we'll hit that in a second. All right, let's do another example. Now I've got this all in terms of rectangular coordinate, or rectangular equation, excuse me, and we want to make it a polar equation. So we just discussed this, and so if you didn't remember it, now you do. Anytime I've got this like x squared and y squared, it's going to be a circle. So if I were to graph this on a normal graph on your graphing calculator, this would make a nice circle. Instead, now we're going to turn it into a polar equation that we could also graph, but this would be in the polar form. Again, I'm going to go back to my conversion page, because if we get r squared or x squared plus y squared, we're allowed to replace that with r squared. If we get x by itself, we can replace that with r cos theta, or if we get y by itself, we can replace that with r sine theta. So those are kind of the things we're looking for. So I'm going to go back over here. I already have an x squared, but I don't, or I have a y squared, excuse me, I don't have an x squared. But what I could do is FOIL this guy out so I can get an x squared. Now x minus 3 squared, is that x squared minus 9? No, that is ridiculous, right? It's the same thing as doing x minus 3 times x minus 3. X minus 3 times x minus 3, which we know is going to be x squared minus 6x plus 9. And then I carry everything else down, plus y squared equals 9. Okay? Well, if I am able to do x squared and y squared by themselves, we're able to make that r squared. So we're going to kind of rearrange. I'm also going to move my constant to the other side to just simplify, or in this case, it's going to completely get rid of the other 9. So 9 on both sides completely factors, or gets rid of that. So now I've got x squared plus y squared minus 6x equals 0. I'm going to move that that 6x to the other side just to make things a little bit cleaner too. I could have done that on the step above, but even if I didn't see it, I can move it now. Okay, now this is key, and this kind of looks like what we got into step 2 in this equation right here. I had r squared and I made it x squared plus y squared, and I had r cos theta and I made it x. Now I'm going opposite. Now I have x and I'm going to make it r cos theta, and I have x squared plus y squared, I'm going to make it r squared. X squared plus y squared, that's the same thing as r squared, and then x is the same thing as r cos theta. So r squared equals 6 r cos theta. We don't want r squared. We've got an r on both sides. Divide by r equals 6 cos theta. That's it. That's my answer. And that looks a lot like that first example we did, doesn't it? They look very similar, so that's an okay answer. That's an okay example of what a polar equation looks like. All right, same idea for the next one. This one's going to be a little bit different because it's got x squares and y squares and numbers in with all of them. So first thing, like we did on this last one, is you got to FOIL. So x minus 3 squared, x minus 3 times x minus 3. If you're not going to mess this up, you don't have to write it out, but I want us to make sure that we're not careless and we don't do x minus 3 squared and get x squared minus 9. It's not right. And then y minus 2 times y minus 2 still equals 13. Okay, so I get x squared minus 6x plus 9 plus y squared minus 4x plus 4 equals 13. All right, cool. All right, now we're going to start moving things around. Ooh, why did I write an x there instead of a y? Be careful, don't be careless. Like I just was, be very careful. Okay, so I'm going to minus 9 and minus 4 from both sides. Minus 9, minus 4. I'm going to put my x squared and my y squareds next to each other. If I minus 9 and 4 from both sides, that's negative 13ths, and those cancel out. So I'm also going to move my x and y to the other side. So I'm going to add 6x, add 4y. So then I get positive 6x, positive 4y on this side. Now it's time to replace. X squared plus y squared is the same thing as r squared. X is the same thing as r cos theta, and y is the same thing as r sine theta. Everything else stays the same. My equal stays the same, my 6 stays the same, my plus and my 4 stay the same. I only replace x, I only replace y, I only replace x squared plus y squared with the other pieces. And just like we did before, I already have this. I have r squared, I've got an r, I've got an r. So you can divide by r from all three pieces. That just kind of helped me get to where I want to be. So r equals 6 cos theta plus 4 sine theta. That's it. Okay. The last thing I want to talk about is this graphing. So I've kind of mentioned graphing a couple times in here. If you're going to graph, you need to make sure that you're in the mode polar. So on your graph, it goes like function, F-U-N-C, and then it goes parametric, P-A-R, and then it goes polar. If you have a nice calculator, maybe it spells those all the way out. But like my TI-83 just says func pol po or something like that. So make sure that you know what's going on. You're going to select polar because we're in the polar coordinates. When you graph it, make sure that your graph is in radians, that it will look better and be smoother that way. But when you're doing calculations, switch to degrees. So like the first couple examples, you need it to be in degrees. And then a good thing to do is put it in z-square. I think that does a pretty good job of framing it where it needs to be and making sure it's in the right window. But don't be afraid to play around. We talked about what all of these should look like. A lot of them are circles. This is a circle, this is a circle, and then on this page, this first one was a circle, but the second one was a vertical line. So I would graph these and see if you can get what they say that they're going to be. We know exactly what this graph is going to be, and even though we didn't write it on these two, you could know exactly what the center and what the radius on both of these examples are. So go ahead and try that out. If you need any help, email me or catch me on Google Hangout. All right, stay tuned for the next video.